video, we'll solve this question. We'll look at the region bounded by these three curves with x positive and give a sketch of the region, set up integrals for the area of this region using both vertical slicing and horizontal slicing. All right, so let's start. So if you're not given a sketch, I would always start by finding intersection points, then placing them and then drawing the region. If you don't know which curve's on top, which one's underneath, which one's right, which one's left, you just plug in points between those intersection points. In this case, I have three curves, which makes this problem a bit harder. I'll solve for intersection pairwise. I'll look at when these two curves intersect, when these two, and when those two intersect, and I'm going to place those. So step one, intersection points. So let's look at the first two. If I set the two equal, I get that x plus 4 is 6x minus 21. So 25 is 5x, and I divide by 5, I get that x equals 5. So my first point is 5, 9. And let's double check. Yep, that works. So my first intersection point is the point 5, 9. Now I'm going to look at where these two intersect, and then finally where these two. So let's put a line. If y is x plus 4 and y is 12 on x, to solve this one algebraically, I want to multiply by x. Then I'm going to get a quadratic equation that we can solve either by factoring, by completion of the square, or by quadratic formula. If I multiply by x, I end up with this quadratic to solve, and so I'll get 12, 6 and 2 to get plus. I'm going to use plus here, minus here. So I get two intersection point. I get minus 6 and 2. If you look at the question, I asked that x is positive, so minus 6 will have to be ruled out. So my point would be x equals 2, and I could get y from either. Y will be 6. Alright, so I've done these two and those two. I need to look at the last two and find those intersection points. So I need y equals 6x minus 21. And y equals 12 divided by x. Again, it's going to look a lot like the last one. I'm going to multiply by x. Right? If I want to use a quadratic equation, that's fine here. 12, 21, let's look at the quadratic equation just to make sure. I get minus b plus or minus square root of b squared minus 4ac divided by 2a. So I get 21 plus or minus root of b squared minus 4 times 6 times 12 divided by 12. All right, so I got 4, or what's the other one? Minus a half. Again, I'm going to get rid of this because our x is supposed to be positive, so I get x equals 4, and then y is 3. All right, so if you wanted to factor this, that's fine too. You would have gotten x minus 4, and then 3, 6x plus 3. Right, so because we have 3 curves, we had a lot of algebra, but none of it was especially hard. That part was the hardest, but if you can't see this factorization, just use this. You get the same value. 4, you waste a tiny bit of time, but if you start staring at it for 20 minutes, that's not helpful at all. All right, so now we're ready to sketch. Oh, I have erased one of my intersection points. So the first one was 2, 6. So I have 2, 6, 5, 9, and 4, 3. Since they're all positive, let's move everything off to one side. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so 5, 9. I have 2, 6. And I have 4, 1, 2, 3. So those are the 3 points. So one curve was 6x minus 21, and it went through this one and that one. So let's draw it in green. That's a straight line. One was y equals 12 over x. I pass through these two, so it's going to look something like that. 12 on x. And the final one is y equals, don't have it anymore, y equals x plus 4. So x plus 4 looks something like this. So the region we want is this region way up here, and I want to find its area. All right, so first question was vertical slice, I believe. Alright, so give I'll redraw the region right here. I'll space it out a tiny bit. So I need red, blue, and black. So I'll have red, that looks like this. And that was x plus 4. I need blue. On x, and I need green. minus 21. Now I'm using vertical slicing. That means I'm going to divide my region into little sticks standing up. So I'm going to look at sticks, and I'm going to look at more sticks. And because I'm using vertical slicing, my variable is x. And the important points here, here, and here, I have x values 2, 4, and 5. So my area here is the integral from a to b of top minus bottom. Top will always be y equals x plus 4, no issues there, but bottom will switch. Bottom at first is the blue curve, and then it becomes the green curve. So bottom is y equals 12 over x, and then y 6x minus 21. All right, so that means I need to split my integral at 4. So I'm going to go from 2 to 4, and then from 4 to 5, because at 4, bottom changes. Top is always x plus 4, so for both, I'll have x plus 4. Then bottom is blue at first, so y equals 12 minus x. And then afterwards it's green, so afterwards it's 6x minus 21 dx. Because bottom changes, I'm going to have to use two integrals in this case. Let's look at what happens if I use horizontal slicing. So in this case, I will redraw the region as well. Part of the reason I'll redraw is I don't want to label the curve with y equals a function of x. I want to isolate x. That's what we need for horizontal slicing. So I'm going to isolate x in all of this and relabel the curve as x equals a function of y. All right, so I have red, I have blue, and I have green. So for red, I had y equals x plus 4. I'm going to get x equals y minus 4. So that's the red one. That's x equals y minus 4. Let's do green. Green was y equals 6x minus 21. It's going to turn into x equals y plus 21. That's going to be 6x, so x is y plus 21 divided by 6. So that one would be green. Final curve is y equals 12 on x. That would mean xy equals 12 if I multiply both sides by y. And then I'm going to isolate x because that's my goal. I'm going to get x is 12 on y. So don't forget this. If you want to use horizontal slicing, you have to have x isolated. If you use vertical, you have to have y isolated. So blue is x equals 12 on y. slicing, which means that my little sticks are sleeping. Again, if I move up, one of the sides is going to switch, in this case from blue to red. So that means left is going to switch from blue to red. So left is going to be blue at first, and then right is not going to change, so y plus 21 divided by 6. So in both cases, we needed two integrals. So in this case, both are perfectly fine solution. The first one would be a tiny bit faster because I wouldn't have to do this work here of solving for y. So the area would be the integral c to d, right minus left, dy. Now left changes, so at first I'm going to have right equals y plus 21 divided by 6. Left is going to be 12 on y. And afterwards, left would be red, so y minus 4. I'm missing something. Can anybody tell me what? I don't have bounds. So this would not give me a number like the area should be. It's going to give me a function of y. So this is not helpful unless I can figure out what the bounds are. So bounds, my variable is y, so there should be bounds for y. So let me draw the y-axis right here. We found the coordinates of these points. At the moment, I don't remember, so let me go look. 3, 6, and 9. So the y value here was 3. The y value here was 6. And the y value here was 9. That means 5. All right, so those were my 3 points. So I get 3, 6, and 9. This was green minus blue, so this is from 3 to 6. And then from 6 to 9, I get green minus red. All right, so this integral will give you the area of the same region as the first two. But now we're using y as our variable, we're using horizontal slicing instead of vertical slicing.